Hello, I'm Yoon-Hwan from Joseon University, who is in charge of presenting about the performance improvement technology, machine learning in a simulation-based 5G small cell mobile communication system. My presentation is about research on how to improve the performance of 5G telecommunication, which is currently being implemented worldwide. In order of presentation, I will introduce the introduction and related technologies, explain the system model, and then present in order of simulation result and conclusion. Introduction. Mobile traffic is showing a huge increase due to the video content market such as YouTube, which has developed since the advent of the post-generation LTE system. Emerging due to the rapid increase in traffic, 5G mobile communication technology aims to satisfy high speed, low latency, high energy efficiency, and a large number of devices. Five generation mobile communication system use high frequencies and are subject to tremendous interference from moisture or windows. Small cell technology, which has emerged to overcome these shortcomings, is a technology that can improve system performance by using coverage expansion and frequency reuse in existing LTE systems, which can be proposed as a solution in 5G mobile communication system. Small cells leverage the license band of existing cellular systems and reduce communication distance for many users by configuring ultra-dense network that place a large number of small cells in a given area. But with large small cells, interference is essential. In this paper, we tried to improve the existing 5G mobile communication performance by using machine learning technology for basic small cell application and small cell connection. And simulations showed that there was a higher performance improved compared to existing 5G mobile communication technology. Next, I will explain the related technology. First, I will explain about the 5G generation mobile communication system. Fifth generation mobile communication was developed based on LTA probe technology and is also known as new radio because it utilizes new frequencies such as 35 GHz band and 28 GHz band. 5G mobile communications defines eMBB and URLCC and MMTC. The eMBB is a technology that enables high capacity transmission using large bandwidth at 5G and support 8 times faster than traditional 4G LTE service using 400 MHz band based on millimeter wave of 28 GHz. The latency of 4G LTE is 10 milliseconds, and there is a URLC that improves this latency by more than 10 times to 1 millisecond, implementing high reliability and ultra low latency. URLCC is a technology that allows remote control of things such as telemedicine service. In addition, there is an MMTC that allows the IoT device or a large number of devices to access. And our goal is to support 1 billion connections per 1 kilometer area. The ultimate goal of 5G mobile communication is to enable high-speed, ultra-low latency service using high frequencies. However, the use of high frequencies leads to huge path losses. Path loss is typically the received signal power PRX as in the following expression, which is the scale of the frequency for the transmitting signal power PTX. GRX is the transmit antenna gain, GRX is the receive antenna gain, and R is the distance between the transmitters. Comparing 2.8 GHz and 28 GHz, the path loss is valued as minus 41.4 decibel and minus 61.4 decibel respectively, indicating that the path loss value is very large when using high frequency band. Small cells are small power base station equipment and have the advantage of having a lower construction cost and a smaller size than macro base stations, making it easy to build in a specific space in a short time and low maintenance cost. Small cells are divided into femtocell, picocell, and microcell, depending on output power. Small cells are on technology that can be composed of multiple APs within a cellular system, which can be expected to resolve shaded area or increase transmission capacity, and can improve system performance by reusing frequencies within cellular systems. In 5G systems, performance can be improved by applying small cell technology, which solve large path losses due to high frequencies using and low communication quality. Machine learning is a technique in which a computer learns patterns or rules of data by a machine learning algorithm on its own without programming and predicts outcomes for new data. Learning algorithm is machine learning utilize artificial neural network and are typically classified as supervised and unsupervised learning. Supervised learning is divided into regression and classification, and depend on the algorithm of the classification model, k-nearest neighbor, and support vector machine and decision tree model are representative, and regression model predicting result for a given input are key. A linear regression aims to run a linear model that predicts real-world data and is a model that generates the data distributed arbitrarily to a single straight line by modeling it to y. The changes depend on the variable x. Linear regression models are divided into simple and multi-models and use multilinear regression when making predictions to consider a number of factors. Logistic regression. If the problem that needs to be solved in classification, the real rabbits of the classification problem and the predictions of linear regression model are solved by finding and linking monotonic differentiable functions, and no direct model creation and presumption of prior data distribution is required. Decision tree is similar to the process by which humans think and make decisions, usually with the single root node and multiple internal node, and a leaf node below it. The sample set of each node has excellent generalization performance with a structure that is classified as a subnode after testing. Soft vector machine is a model that determines the decision boundary and defines a decision boundary by selecting a support vector from a large number of data points to classify which side of the boundary belongs to the new data. I explain about the system model. A main base station existing in the center and place the small cells in the cell at random. The base station has a radius of 1 kilometer and assumes an environment that is subject to interference from 6 nearly base stations. According to the low power of small cell communication outage is less than 10% until 10 meters, but it increased rapidly when 20 meters is exceeded. So we set it to the within 10 meters by default. Due to variable in real-world environment, typical small cell deployment or application of algorithm can also be a factor that can degrade the system performance. For example, if you make a decision about using macro cell and small cells with SINR or capacity, you may have a problem with connecting multiple terminals to a specific base station and decreasing system performance. To address these problems, we perform a method to learn by the system itself using machine learning algorithm in small cell connection decisions to find the optimal method. The 5G small cell machine learning algorithm provides SBS, MBS, and user locations, SINR, and capacity as basic data, and labels each data on which side of macro communication or small cell communication exhibit high performance. The machine learning algorithm applied linear regression, support vector machine, logistic regression, and decision tree, and made improvements on the best performing support vector machine. The improvement performance method take a during training approach, adding to the process of evaluating and selecting data by applying a small cell on-off approach to the first training data set. The graph on left compares 5G communication with macro system only and small cell technology. When small cells are applied to macro systems, they can be observed to perform better than traditional macro systems. The figure on the right shows that the location of small cells and users and activated small cells when small cells are applied into 5G macro communication system. The left graph compared the values and labels predicted by the model for machine learning algorithm that determine macro cell communication and small cell communication, and showed the high-risk prediction in the proposed SVM model, and the occurrences of applying double training to SVM algorithm increased. The graph on the left shows system performance when logistic algorithm are applied to 5G small cell systems, with a 44% increase on overall performance. The graph on the right shows that the result of applying decision tree in the 5G small cell machine learning algorithm and shows a 24% increase overall small cell systems. The graph on the left shows that the capacities of the 5 small cell machine learning algorithm when applied with soft vector machine compared to conventional small cell technologies. It can be seen the overall performance improved by 44%. The graph on the right is the result of applying dual training method as previously described to SVM algorithm that exhibit high occurrences and performance among 5G small cell machine learning algorithm. When using the proposed method, we observed a 69% performance improvement over conventional small cell systems and approximately 8% performance improvement over SVM algorithm. Conclusion: the data traffic that increased due to the activation of video streaming service due to the development of the mobile communication system was not affordable with the existing 4G LTE system. In response to this change, 5G mobile communication technology is a technology that meets the acceptance, low delay, and high-speed mobile communication of a large number of devices and use higher frequencies than 5G mobile communication technology. Using high frequencies has also affected pest loss and moisture in air, which led to the study of small cells to solve this problem. When establishing a UDN environment where countless small cells are deployed, communication distance is reduced, which can improve communication performance, but interference management is essential due to interference. To solve this problem, we could check the performance improvement part of each algorithm by applying the machine learning algorithm to the small cell connection decision tree step, and double training on the SVM algorithm with the high risk accuracy and performance was able to see the high performance improvement. More small cells will be deployed as a solution to high frequency use, and research on this area will continue to be conducted in the next generation of mobile communication system. Thank you for listening to the presentation.